to entire screen. I record. Forget to pull this one. Okay, we are going to continue with this synchronous counter. And as the name, okay, imply here, synchronous counter, you will find that, okay, this counter, all the flip-flops here responds to the same, okay, control input, which is the clock. Okay, clock is the one that control. So therefore, in this case here, they have fixed time. So every time, okay, a clock pulse comes in, okay, be it, okay, rising edge or falling edge, all right, you are going to find that there is a change at the output there. Okay, or the count here is going to change. Okay, so they are all controlled by the common clock. So all response at the same time. So when we are designing counter, most probably we are going to use JK or T flip-flop. Because, okay, for the case of counter here, you always find that the output always keep on toggle. So we make use of the features in the T flip-flop, the toggle features. And the JK, we tie the J and K together to form the T flip-flops. So that, okay, so this JK actually has been converted to become T flip-flop by joining the J and K together and then connect to a logic 1. So with this, okay, you find that their toggle mode are used, okay, for counter operations. All right, next. Okay, so just a little bit of general knowledge again. So a 3-bit synchronous binary counter here, 3 bits. Okay, so I expect, okay, this counter here count in terms of binary. So they will count from 0 to 7. All right, count from 0 to 7. So in this case here, this is a present. Okay, this one will form the next count. Present count, next count. Then this one present, next. So the count will keep on continue. As time goes on, okay, they will start counting from 0 to 1, 2, 3, 4, and so on. All right, up to 7. Then they repeat. Okay, repeat. And usually when they repeat, okay, we can stop already. All right, because we can just write here as a repeat already. No need to keep on writing. Okay, so we look at this counter here. Now this counter here with additional, okay, control input clear. Okay, and this clear here is active low. Active low. All these clear here are connected, okay, to the common control input clear. So that is to say in this case here, if I put a logic 0 to it, a logic 0 to it, my output will be all 0. So because we say clear the output. And this part here, normally we do it in the beginning. All right. But of course, we do testing that time. We have to make sure that this clear is working. So therefore, in the middle, okay, we put a 0 to see whether my output of this counter here will become 0 or not. To test, okay, the functionality of this clear here. All right. So for this counter to work in a normal way means that be able to count from 0 to 7. Then you have to make sure that these are 0, okay, got to be changed to a logic 1. So if you put it to logic 1, you actually disable it. So say that, okay, count, you are not working anymore. Okay, you disable, disable it means that clear, you are not working anymore. So we disable the clear by putting a logic 1 here. So with this, okay, then this flip-flop, okay, by right should work in a normal way. By right, But then, okay, you see at this counter clock here, the clock here, okay. So instead of directly connected to a clock, we put in an extra input pin here. It's called inhibit, okay, or something like your enable. Okay, enable. I want to start the count or not. If I want to start a count, I put a 1. If I don't want to start, okay, I put a 0. 0 in this case here is your disable. So I don't want the count to start because, okay, they end this clock with this inhibit or enable input here. So if this is a 1, okay, if this is a 1, then your clock, we know that, okay, clock is this type of signal. So whatever is the clock input will be channel or becomes the output of this AND gate. All right, provided this is a 1. Of course, when this is a 0, whatever is a clock input, sorry lah, your list output here will be a 0. And 0 in this case here is a constant 0. All right, so that your clock in this case here will never work, because in my list clock here, I need a edge trigger, falling edge. Okay, falling edge trigger for it to work. So I need this type of a signal coming in. All right, so when you are doing any design, okay, you can add in extra, okay, control, okay, extra control, okay, whether you want it to start working or not, and so on, or we make use of a button to control, okay, the operations of the whole counter here. Okay, then in this case here, now we try to understand a little bit about this layout. Okay, we actually can design it. Okay, later on we look at it. So my clock here, several clock pulses. So label as 1, 2, 8. Okay, clock number. And every of this clock here, what I'm interested in now is a falling edge. Okay, falling edge because of these parts here. Okay, so at the falling edge here, therefore you see some projection line coming down. All right, and next, okay, we look at flip-flop 0, always connect to a logic 1. Okay, this is a logic 1. That is to say that my flip-flop 0 is going to forever toggle. Of course, with falling edge comes in, they are going to toggle. For flip-flop 1 here, whether they are going to toggle or not, it depends on the Q from FF0, or we call it as Q0. So my T1, okay, flip-flop 1, so this is labeled as T1. T1 depends on Q0. So if Q0 is a 1, I toggle. If 0, remain. Okay, for the case of T2 here, flip-flop 2, so this is T2. T2 actually same as, in this case here, Q0, Q1, okay? So I put here Q1, Q0. Unless both Q0 and Q1 are 1, all right, otherwise, okay, you are going to find that my T2 is going to remain unchanged. So this is 3 bits. So we put an extra here, overflow, to tell the counter that, okay, you count up to a maximum already. Okay, maximum 7 already. Optional, all right, optional, okay. So I can indicate, okay, I already count to 7 over here. And also, okay, this part here can be used, okay, to cascade. So instead of 3 bits, you want to form a 4 bit. Okay, you just connect. This one becomes an input to your T3. All right, and this one here is given as Q2, Q1, Q0. All right, so it can be cascaded to your T3, okay, if you want to form the 4-bit synchronous counter. Okay, so with understanding of this circuit here, now we look at the waveform. In this waveform here, we know that it is key on, okay, going to respond to falling edge. And let's say, okay, our count for all these start from 0. That means we clear it first. Then you find that our Q0, okay, Q1, and Q2, okay, these are the 3 outputs that we are going to see, all start from 0. Okay, this one every time toggle. So falling edge, I toggle, 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 and so on. So you find that the output of this Q0 here, in this diagram here, purposely want to draw to show you, okay, later on the grids over here. So you find that they take a little bit of time to react. So they don't change immediately, okay, when falling edge come. They will change slightly after. This slightly after could be is 10 nanosecond or 20 nanosecond, depends on the specifications of this T flip-flops. All right, so you find that, okay, after maybe take example here, 10 nanosecond, it is going to toggle from 0 to 1. Then, okay, clock pulse come in first, okay, they check here. Now, okay, my output is a 1, I'm going to toggle to make it become 0. So they keep on toggle, okay, for the case of the Q0. And with a delay of, example, 10 nanoseconds. All right, that is the Q0. Okay, Q1, okay, we'll take this one here as the input because the T1 actually same as your Q0. T1 is connected to Q0. So they take this one as the input. So first clock pulse comes at time, they check, hey, yeah, I'm at a 0 here, okay? My input is a 0. So I don't toggle, remain. Clock pulse number 2 comes, check what is waiting here is a 1. Check what is in front, signal in front waiting. Remember the setup time? All right, the setup time. So the setup time here sufficient, then saw the 1 here, then they are going to toggle. Whereas here is a 0. They see a 0 waited here, so don't toggle, okay? Sorry, I made a mistake, here. Yeah. Okay. Correct, So Q1, Okay, 0, they see a 0 here, they don't toggle. Okay, so this is the output that we are going to see. They don't toggle. This part here is a bit confused. Okay, they don't toggle. Okay, then clock pulse number 4 come in and so, okay, what is waited there? 1. So I toggle. Okay, toggle until I see another 1 again. Okay, another 1 again, then I toggle. Okay, I see another 1 again, I toggle. Go. So every time when you see a 0, just remain, because that is the features of the T flip-flops. Okay, features of T flip-flop. So for the T1, you actually see the waveform pattern is this one. So you compare the Q1 output with the Q0 output. You find that, okay, Q0 output keep on changing as with every clock pulse. Okay, but Q1 change every 2 clock pulses. So from here to here, okay, it's 2 clock pulse already. Then you see, okay, they only start to change. So every 2 clock pulse you change. All right, that is the Q1. So in this waveform here, there's an additional output combining the Q1 and the Q0 and them together, which is the output from here. All right. So this is why they hatchet this part to indicate to you when both are 1 at this case here, you find that, okay, I'm going to get a 1 for my Q0 and Q1. All right. When both are at 1, I got a 1 here. And because of some small delay here, although we say that, okay, this is a 10 nanosecond, this is another 10 nanosecond, and so on, seems like, okay, they are no delay timing is the same. But this one react first. This one will react later. So say now, for example, okay, this one delay time here is 10 nanoseconds later, but this part before, okay, it goes up. It can be faster or slower. So it is possible to get a glitch. Although we might thought that this one here, the delay timing is 20 nanosecond, no problems. You may thought that is no problem. But okay, remember, we need to have the whole time and so on, okay, for it to react. So there might be suddenly, okay, a small logic 1 appear, okay, which we call it as glitch. Same thing happens here. There might be, okay, a glitch happen. But this timing here is too short. And also, okay, it's after the falling edge already. So it will not, okay, affect your final output. And this is a good thing that we say that, okay, the response time for this flip-flop here is very short. So whatever glitches, okay, happens in the middle, okay, in between the two, okay, falling edge in this case here, will not be shown at the output. In this case here, our Q2. So they eliminate all these glitches, okay? So will not be seen. But if you do simulation, you will see this lah. All right, you will see this. Final output, the count, okay, cannot. We don't show it, okay? But you do simulation, if you add in these combinations, you see these glitches. Now, this is because of, okay, these parts here, okay? The delay timing may not be exactly equal. Okay, then now we look at this Q2. Now Q2, okay, their input, okay, is coming from here. So I need this one here to be a 1, then only I am going to toggle. So whatever here, but because the input is a 0, so you find that my Q2 output remains 0, until clock pulse number 4. Okay, number 4, see what is in front, then you saw a 1 here. Okay, release 1, okay, at the input T2, you find that now I am going to toggle. After toggle, you find that, oh, input is always 0, 0, so I remain, okay, remain at 1. Until clock pulse number 8 appear and saw that, signal weighted here is a 1 again, then I toggle back. All right, so if you were to arrange your signal now in this form here, you're going to find that first input 0, 0, 0, second 0, 0, 0, 1, then third 0, 1, 0, okay, third 0, 1, 0, then 0, 1, 1, all right, 1, 1, 1, 0, 0, 1, 0, 0. All right, so it goes follow this sequence. All right, so when it comes to simulation, be alert. If you see small creatures here, nothing wrong with your design. It's just because, okay, flip-flop requires some time to react. Okay, next, okay, now we are going to sort of go through the design. So like I said just now that we can actually design out this circuit if we know, okay, the state, okay, of the output that we want. Okay, we want the output state to be like this, then we do a design. Okay, so now this design here, okay, whenever you are doing a design, you must know what you want to design. That is what we call problem definition. We must know what we want to design first. Then we draw out, okay, these are state diagrams. So from our understanding here, we convert it into a diagram. Okay, diagram something like this. Okay, this is a state, this is a transition path. Okay, so state, transition path, go to another state. All right, so we'll look at it afterwards. So from diagrams, we are going to build a table. This table here can be quite simple or complex, okay, whether you are going to add in the input of the flip-flops or not. Okay, if you add in the input of the flip-flop, okay, later on when you fill in into the Kano map, it will be easier. So anyhow, third steps here is trying to build, actually convert this state diagram, put it into the state table. Then decide on what type of flip-flop that we are going to use. And we fill in, okay, based on the application table of our flip-flops. Okay, after doing it, we might need to double check, okay, whether we have any redundant state. Okay, so we go through state minimizations systematically. Okay, we are going to go through these steps here. Okay, once confirmed, okay, our design is optimum, then we go and have our state assignment. State assignment in this case means that, oh, I'm going to say that state A, for example, I'm going to assign it as a 0, 0. State B, I'm going to assign it as 1, 1. Suka hati lah. All right, if you are the designer. So you can design, you can assign it as a 1, 1. Don't like it, never mind. You can assign it as 0, 1. So that is to say, when you see output 0, 1, then you should know that, okay, this 0, 1 actually representing my state B. Okay, if you see output is 0, 0, or it represents that I'm at state A. Okay, this is what we call state assignment. But of course, in the exam, I assign for you all lah. If not, okay, I will have say for example 3 input I will have 8 set of answer to mark. I go gila already. Okay, so this is how if you are the designer, you can decide on this. Okay, then after that you implement the circuit. Okay, draw up or construct, build the circuit. All right, so this is a standard design procedure. Then now we look at an example, and then based on this example here, we are going to go through this process. Okay, so this example here, first thing we need to know is understand what we want to design. So here I say that design digital systems which detect the occurrence of the sequence. Detect the occurrence of the sequence. Okay, so first time must be 0, 0. Second time still 0, 0. Then 1, 1, 1, 0. Okay, on 2 parallel input wires. Okay, X1 and X2 means that this is for your X1 now, this is for your X2, X1, X2, and so on. And only after these whole sequence being detected, then they will give you an output of unity 1. Output show you a 1. Okay, if I detected all this, my output will be a 1. So what is inside here? You design. Okay, so we understand by this way here. Then now, how we are going to start off it? We understand our problems already, problem definitions, clear. Then next step is convert what we understand here into a state diagrams. Okay, convert it into a state diagram. So state diagram very important, because the moment your state diagram is wrong, then your whole design will be wrong. All right, so I definitely will start here. So I'm going to follow the notes label. So I'm going to start here with a state called state 1. So this state 1 is my initial state, starting state. So my state 1 says that I will need to detect this one. I do the correct one first. I need to detect both are 0. Then only I move on to state 2. Then if I'm at state 2, I need to detect another 0, 0 for me to move on to state 3. And now it's 1, 1. 1, 1 for me to move on to state 4. All right. Subsequently, last one, I need to detect 1, 0 for me to move back to move to state 5. You may think it as this is the state 5 that I'm going to go for. But I can also say that they can keep on detect this whole process. Therefore this parts here I can say that so once I detect 1, 1 already, then you go back to state 1. If you detect a 1, 0, so how to differentiate that? I successfully detect the whole thing. My output is a 1. All this, their output are 0, to indicating they are in the process halfway of detecting the correct sequence. So by doing so, you find that this part here is actually redundant. So I am not going to have a state 5. So I make it go back to state 1 to repeat the whole process if you want to. So this system here, you can think about it, is like your peti keselamatan safe the safe box. So you must turn left 3 times, right 4 times, for example. Then turn make sure it is correct. Then the door will open. Open means that output is a 1. to activate the door open. So the sequence must be correct. If the sequence is wrong, sorry lah, you got to repeat. Okay, you got to repeat. So it's like a safe box over here. Now, this is the correct sequence. All right, so if I start from here, everything correct. Okay, my door open. But there is a possibility, okay, I might make mistake in setting, okay, these conditions here. So if initially, okay, I forgotten, okay, I didn't put 0, 0, but I go and put, you see, because it's 2 input, you are going to have, okay, 0, 1, 1, 0, as well as 1, 1 as the combinations for your x1 and x2. Therefore, you find that there might be a possibility that, okay, you didn't input this. Instead, you go and put in this one as the input combination. Therefore, in this case here, my system will tell me that I'm not going to move. I'm going to stay at this present initial state. And my output, of course, is still 0. My door will never, the door will never open. Okay, that make it, okay, stay at 0. And stay at this initial state here, my door close. Output remain as 0. All right. Okay. If now successfully put a 0, I move on to state 2 now. In the case of state 2, you actually already remember that, oh, just now I got this is correct. Okay. So I remember just now, okay, it's 0, 0 if I'm at state 2. This is like saying that, okay, you finish your primary school, now you go to secondary school. I must finish primary school first, then only I can come to this secondary school. All right, so process is a process. So now I'm in the state 2 now. Okay, so I want to have another 0, 0, but there is also a possibility that you didn't input this, but you go and input different combinations. All right, you input different combination. Therefore, in this case here, you'll find that you fail lah, because, okay, after you input a 0, 0, okay, you first input 0, 0. Second input, okay, you go and put in now is a 0, 1 or 1, 0 or 1, 1. Then I cannot say that, hey, continue from any of this. So my sequence is wrong. Therefore, in this case here, I will need to go back to initial state, restart the process again. Okay, with this one going back, you find that, okay, my door will still remain closed. Okay, my door will still remain closed. Process wrong already, so please repeat. Okay, subsequently, if, okay, I got it correct, 0, 0, then I can go to state 3. State 3, I remember first time is 0, 0. I also remember that the second time is also 0, 0. So 2 times correct already. This is correct. This is also correct. All right, if I can manage to go to state 3. Then now there is a possibility, although, okay, you put in 0, 0, second time you also put in 0, 0, but third time instead of put in 1, 1, okay, you go and put it as 0, 0 again, or 0, 1, or 1, 0. Something is wrong, okay, not 1, 1. You go and put this. Then we examine, okay, all this. All right, if I put a 0, 0 here, okay, if I put a 0, 0 here, you see, you have 0, 0, 0, 0, another 0, 0 comes in. Can I continue the process? That to say that, forget about this one here. Take this one as the first one, this one as the second one. In this case here, answer yes. Okay, you find that, okay, I discard the first 0, 0 combination, and with this, I go back to state 2. Sorry, I make a mistake. Okay. 2 times 0. Now, if okay, this is a case here, I remember this one as first combination of 0, 0, second combination of 0, 0. So in this case here, 0, 0. Then I am going to stay here. If a 0, 0 comes in, of course the door still remain closed. That means I never proceed, but I am going to stay at state 3. So if you put in another 0, 0, they also stay here. Another 0, 0 still stay here. So they will forever stay at state 3. If your combination, you only manage to put 0, 0, 0, 0, 0, 0. All right. So we covered this one already. What about if, okay, I make a mistake by putting in 0, 1 or 1, 0. Then you are going to find that totally wrong because you have a 0, 0. Okay. You have 0, 0. Managed to come to third. Then now I put in 0, 1. So can I take any of this sequence here? Answer is no. If answer is no, then you start all over again with if your input is a 0, 1 or 1, 0, your output or door remain closed. Okay, that is when I'm at state 3. Okay, lastly now I'm at state 4. Okay, if I can come to state 4, that means to say that, okay, I previously already have 0, 0, already have another 0, 0, and 1, 1. That means that this one, and this one now. Then only I can reach the state 4. Okay, so if in state 4, I expect to get 1, 0 so that door open. But you know lah, not necessary you're going to get this. What happens if I input, okay, 0, 0, and all other combination except this one, I input a 0, 1, I also input a 1, 1. So what is going to happen? So we check this one first. So if I input this as 0, 0 here, that is to say that the sequence that you put in so far is 0, 0, 0, 0, okay, 1, 1, then you put in 0, 0 again. With this 0, 0 here, wrong already. All right, wrong already. Because what I want is 1, 0. Okay, wrong already. Never mind. I will start from somewhere, continue from somewhere. This continue from somewhere is here. Okay, so you want to take this one as the first one now. Then you go and check which is the one that remember only this first combinations of 0, 0. That is the 2. Therefore, from state 4, now you go backwards, okay, to state 2. If you put in a 0, 0. All right. So that is to say that you have to complete the process 0, 0, 0, 0, 1, 1, and 1, 0. But instead of go back to 1, you go back to 2. Because you take these combinations here as first time correct. Okay, so consider this. Next, what happened, okay, if I put in a 0, 1? Is there any part I can join, okay, to the sequence and start from somewhere so that I don't need, okay, to input, okay, extra combinations? Answer is no, because there is no, okay, 0, 1 combination that I need over here. Therefore, in this case, fail already. But fail already, you restart, okay? You restart means go back to 1. So you restart, go back to 1, but your door, the door output never open. Okay? Other than this, okay, if I put in 1, 1, what is going to happen? Some students say that, okay, I can join from here, No. Then you have 0, 0, 0, 0, 1, 1, 1, 1. Hey, not correct. I want is 1, 0. Why you say 1, 1? No, totally wrong. Therefore, restart the process. Okay, go back to state 1 and you are going to output a 0 over here. Okay, so this is my state diagrams for these systems here. In fact, my list of state diagram here, I really think very carefully. Okay, I don't need to have a state 5. All right, and of course here, this diagram a bit messy, so you can see a better one over here. Okay, and these are the explanation. So this part here, I'm converting, okay, my problem, what I understand by the problems here into state diagram. Okay, so I expect some questions from you all. Any questions? I think I can stop recording for this part. Okay, any questions? Or you want to see this one? Any question? Hey, every year I teach this one, a lot of questions. So quiet. Anything wrong? Okay, mic is on. State diagram, okay, Kibun, sure. Every time, okay, students will ask me, okay, why like this, why like that, okay? So, beside Kibun, other students all okay? I actually wonder, are you all there or not? Corwin, are you all right? Actually, for whole, you means what? Now, this subject here, very easy to pass, okay, if you practice. Why state 2 does not loop itself if it is not 0, 0? Why state 2, okay? Oh, okay, Tamwai asked these questions. Now, why is it okay, never loop itself? Because if I'm at state 2, I got a 0, 0 comes in, correct one, then only I can go to state 2, isn't it? After that, okay, if you say wrong one, okay, the one not correct one, not 0, 0, not 0, 0 means it's the wrong one. Let's say 0, 1, you put in a 0, 1 comes in, or 1, 0 comes in, or 1, 1 comes in. Can I say that continue from here or not? Okay, can I say that, oh, I take this one as the first state or not? Answer is no. Why? Because what you need for the first state is 0, 0. But you don't have all this. That means that, oh, the one I adjust for my peti keselamatan Sarah already. So go back to state 1, restart everything. So this is the why we go back. Okay. go back to restart the whole process. Forget about it lah. I make a mistake already. Okay, I want a 0, 0. So later on, I need another 0, 0. But if accidentally I put 3 times 0, 0, okay, take this one first time, second time. So this is the reason here. They go back. Forget about this one. No, just take this one. Salah again. If I put 0, 0, still remain here because you got 2 times correct. 2 times correct. Still 2 times correct. All right. Until here, you put 1, 1. Okay lah. This one forget. This one forget. First time, second time. This is the third time. Then I can go to step 4. First time, second time, third time. This is what I want. Shall I answer your questions? This is the reason why cannot, okay, because the sequence don't have 0, 0, 0, 1. Shall I? Am I answer your question? Can state 4 back to state 3? Can state 4 back to state 3 if 0, 0? Now, let's see. Now, if I'm at state 4, that means that, okay, if I can come to state 4, that means that, okay, let me maybe clear all this. Okay, if I can go to state 4, that is to say I already have 0, 0, 0, 0, 1, 1. Then now you are saying that, okay, 0, 0 comes in. So can I stay at state 3 or not? So for me to go to state 3, I must have 0, 0. 2 times 0, 0. 2 times 0, 0. But I know, okay, it's very wrong because what I need is a 0, 0, 0, 1, 1. Last one here is a 1, 0. Okay. So you find that, okay, I want the sequence is like this. But up to here now, accidentally, okay, I go and input 0, 0 instead of 1, 0. Then everything wrong, isn't it? Because, okay, because you cannot go back. Is for you to go back to state 3, I must have 2 times 0, 0. But now I take this one as the first time. Okay, first time. Therefore, I need to go back to 2 instead of go back to 3. Because for me to go back to 3, I must have 2 times 0, 0. But now only 1 time. Not enough. Then go back to 2 lah. So actually for the whole design, this is the most difficult part. Any other question related? Now, for me, want to kill the students, fail the students in the exam, I said, okay, these are our questions, then the students sure fail one. I mean, for this topic lah. Okay, of course, okay, different combination, different state diagram. So we need to understand and know clearly, okay, what is the combinations that we want. All right, if no question, then can we proceed? Or do you need a break? Or need to digest and ask me the question again later? Okay, we take, say, like this is 57, 5 minutes break. Okay, 5 minutes break. Then we continue with the solutions. This part here quite standard. Okay, I think we can do it very fast. Or one is open. I take the example as one is the door open. All right. Okay, that means that successfully open the safe box already. Okay, so if it's wrong, of course the safe box, the door cannot be open. All right. So it's to just to differentiate for understanding only. It can be any other things. Okay. Uh, make like a alarm silent. Okay. Make some sound or whatever. Okay, that you connect to it. Okay. Take 5 minutes break. Okay, and then if you need to go to toilet or so whatsoever. So all four we come back. Continue. The rest, okay, please think about it. Okay, we continue here. Now, after this break here, anyone find that okay, certain part okay still don't understand for the state diagram? Yinxuan, are you okay? Yinxuan, are you okay? Okay, qua. Okay, qua. This qua, okay, is a question mark. All right. So anyway, digest it. Okay. If still got problem, Monday ask. All right. Now we got to sort of okay design these parts here. So of course, okay, you may say that this part you have learned it before lah. All right. But last time we never go through this. Okay. So now how am I going to sort of okay design this part here or change these state diagrams here into state table? We will normally put it as okay, start off with the present state. Okay, we have a present state. Okay, then our present state here actually okay depends on how we are going to assign it. But currently, okay, I'm going to just follow this one, 1, 2, 3, 4. All right, so you find out I put it as a present state. Then I'm going to have my next state here. But my next state here depends on the input that coming in, okay? Because it's 2-bit, then you find that, okay, the combinations, okay, will be maybe 0, 0, maybe it's a 0, 1, maybe it's 1, 0, or 1, 1. So for these two here, okay, you can interchange them. Why interchange them? Because of the Kano map. So if I interchange them, you find that when I fill it into the Kano map, it will be easier. So you can leave it as in this form, or you interchange them. Suka hati. All right, suka hati, both are correct. So when I mark the time, okay, I actually very alert of this part, whether students, okay, put it this way or this way. Suka hati. Okay, my next state, they will go to here. This one here is when input of my x1, x2 is this one, this one, this one, or this one. All right. Then next, I have one, okay, extra column here. That is my output. When this part here optional for me to explain, okay. You find that in my notes, I didn't put this one. This is when input equals to either these conditions of 0, 0, 0, 1. Now, since here, if I put 1, 1, then you are going to find that, yeah, class, I forget to record, is it? Suddenly recall. Okay, so we are going to prepare this state table here by labeling all these. So this is something extra to tell you what is all this here. This is actually the input of your X1 and X2. So for the case of output, same thing. I'm going to follow these combinations. Okay, 1, 1, 1, 0. So usually follow. Otherwise, okay, you are going to make a lot of mistake. All right. Of course, okay, the output you can put 1, 0, 1, 1 also. But like I say, okay, standardize it. All right. So in my present states here, of course, these are the 1, 1, 2, 3, 4. So I put here 1, 2, 3, 4. Okay. These are my present states. So whether they are going to go to what states, it depends on the input coming in. Okay, so we start from 1. So when present state is 1, I focus on here. All right. Here says that if 0, 0, I go to state 2. 0, 0, I go to state 2. All other combinations, I am going to remain at state 1. And with this, okay, all my output currently, because not enough sequence, you are going to find that still remains 0. First one. So done for this. So you focus on here. All right. Then next, I focus here, 0, 0 input for my x1 and x2. I'm going to go to state 3. Here, state 3. Okay. If any other combination here, you find that you go back to state 1. And your output for this case here, all are 0. Okay, so done for this part. Third state, current state, 0, 0, I'm going to stay. Okay, I stay. Okay, this is the one, I stay. All right. If 0, 1 and 1, 0, 0, 1 and 1, 0, 0, 1 and 1, 0, you find that I'm going to go back to state 1, initial state. But if it's 1, 1, I will go to state 4. I haven't have enough, okay, sequence to open the door or output you a 1. So my output all 0. Okay, I'm at the last here. Okay, go for the correct one first. Correct one is input is 1, 0 here. I'm going to go back to state 1, but output 1 here, trying to tell you successfully you detect the sequence that you want. Okay, 0, 1 and 1, 1 will also make me go back to state 1, but this is a failed state. So output is a 0 for both cases. And if 0, 0 comes in, I'm going to go back to state 2. But when you go back to state 2, this is halfway of the sequence. So output is a 0. Okay, so this is my state diagram, which I'm converting this, state table, which I'm converting these state diagrams into this table here. All right, so a better one you can see over here, exactly the same. Now for this case here, you find that my states here got 4 states. So 4 states, you need only 2 flip-flops. If accidentally just now, okay, I use the 5, then you find that I need to use 3 flip-flops in the design. Answer may be correct, but you are using more hardware, okay? So not cost efficient. So in this part here, okay, just in case that, okay, accidentally you now introduce a state 5 in the design, then you may need to go into state minimizations. You need to minimize. See whether I can reduce the states over here. So this part here, I'm going to look for equivalent state so that I can reduce the states. So what does it mean by equivalent state? Both input, output are the same. All right. So let's look at this example here that we are producing. Can we say state 1 and state 4 here the same or not? Okay, can we say state 1 and state 4, are they the same or not? Why? Because you look at the next state, 2, 1, 1, 1. Here also 2, 1, 1, 1. Seems like the same. So this is input. But what they are about their output, here all 0, here you got a 1 here. So in this case here, input same, but output not the same. Therefore, state 1 is not equivalent to 4, not the same because of different outputs here. So state 1 and 4 here are not equivalent due to different outputs. Okay, then we can check, okay, state 1 and 2, no, here not the same. State, okay, 1 and 3, no, not the same. State 2 and 3, no. Okay, so eventually by inspections, I can conclude that there's no equivalent states in this design. That to say I never introduced any redundant state. Okay, never introduce any redundant state. So you still can have chance to eliminate any redundant state by doing this type of process. Okay, this is only by inspections. Towards the end there, we will go for a more systematic way of checking whether we can minimize the states or not. All right. Okay. Then now I say, designer, you decide state one, how you are going to label this as state one here. All right. So let's say I am the designer. I decided this. I want state one to be assigned as 00, state two to be assigned as 01, state 3, 11, state 4, 10. Suka hati ya. If you are the designer, you can suka hati say that, oh, this is 11, this is 10, this is 01, this is 00. Also can. Provided you define it properly. All right, you mention properly in your state assignment. If not, we follow this in this case here. So now with this one here, state one indicating 00, you find that from this table here, instead of one here, put one here, I'm going to replace it with 00. And remember just now that we label it as x1 and x2. This is state. This is a state. Okay, I am going to label this state here with a name. For example, later on you find in the design here, I may be using y1, y2. Okay, it's a label only. So you label it as y1, y2 for this. Okay, for the case of 2 here, follow this state table. We find that, state assignment, we find that, I'm going to label this one as 01. This is 11. This is the 10. Therefore, inside here, the 2, you are going to change it to 01. 3 change to 11. Okay, 11. The 2, this is a 2. Then the 0 all remain as 00. This one here is your state 4. All right. Output here is already in the binary form, so you don't touch it. Okay, remain no change. Therefore, in the exam, I normally get the students, this part you use pencil to write, then later on you use pen to write. All right, so that you don't make mistake. All right, so this table will be converted into this binary state table. Of course, if you are good, you can directly convert, provided, you don't make mistake. Everything is okay. All right, so once we got it already, then we have to decide, now what type of flip-flop am I going to use, to implement this circuit? If I'm using JK. Okay, if I want to use JK for it. Okay, so how am I going to fill up this kind of maps here? So student, if you are good already, you can directly fill in into this kind of map. If you are no confident, then from this table here, which we are going to convert it into this binary, we are going to modify a little bit or extend it to get our transition table, also including the input to the flip-flop. So I'm converting this one. So the output part, we don't touch. Okay, so easy for me to see. I erase all this. So you find that, I'm going to copy this. Okay. Okay, so this is my state binary state table. So in this binary state table here, I'm going to extend it. Okay, add more info into it by putting now my input to JK flip-flops. Okay, So you are going to find that, okay, because you have different combinations of input here, then I may have input here when x1, x2 equals to 0, 0, equals to 0, 0, equal to 0, 1, equal to 1, 1, equal to 1, 0. Then same thing, 0, 0, 0, 1, 1, 1, 1, 0. And why I need to prepare 2? Because you have 2 flip-flop that you are going to use. So JY1, KY1. Okay, this one here still JY1, KY1. Okay, JY2, JY1, KY1. For these conditions, all right, for this condition, and these whole parts here is meant for our JY1, KY1, okay, for the input of this. All right, so maybe, okay, I can convert this one here is input to JK flip-flop, and I label here as a JY1, KY1. The second one is input to JY2, KY2. That's it. Okay, KY2. All right. And with this, okay, I don't need to write this part. Right, I prepare this, okay? And for me to fill in this table here, still remember your application table? So I need the application table of my JK flip-flop. So in my application table, remember the Q, Q plus, Q plus, okay? And I put here JK. So 0, 0, 0, 1, 1, 0, 1, 1. So what is the conditions, okay, for your JK such that your state output, okay, remain at 0? Okay, you find that J is a 0, K can be a 0 or 1. Next. What is the condition of JK if I want Q to change from 0 to 1? So this is a set. Okay, set or toggle. So either is 1, 1, 0 is a set, 1, 1 is toggle. Okay, what about this one? This is a reset or toggle. So reset means it's 0, 1. Toggle means it's 1, 1. So J can be anything. Don't care. Lastly, okay, lastly, over here, you find that, okay, my K definitely cannot be a 1 because output is a 1. So my J here can be a 0 or 1. Why? Because if it's 1, 0, set. If it's 0, 0, no change. Okay? 1, 0, set. 0, 0, no change. So this is my application table. So I'm going to make use of this application table fill in here. So maybe you all can help me to fill in very fast. All right, so output, no need to see first. We only see here. So in this case here, for me to look at this JY1, JY1, KY1. Sorry, make a mistake here. Okay, this is Y2, correct. Okay, 1. So for first one here, you find that, okay, what I'm going to do is I look at the first column. Okay, the first column. Okay, the first column. So we take it as 0, go to 0. Always, okay, right at the side there so that you no need to think, because when you fill in this, okay, you got to do it fast. All right, 0, 0. Okay, so I do for all the 4 because I see all are 0. So you find that. All right, 0, 0, 0, 0. Next, 0, 1. Okay, 0, 1. So you find that is 1, don't care. Then subsequently, all are 0, 0. Okay, third one, 1, 1. Okay, 1, 1. So 1, 1 is a don't care 0. The third column here also 1, 1. Then next is 1, 0, 1, 0 for these two. Okay, 1, 0, 1, 0, 1, 0, 1, 0, all are the same as 1, 0. So don't care 1. Okay, that is for the case of a JY1 and KY1. Then next, okay, we look at this different color, maybe green. Okay, we take green with green. I highlight it so that it's easy for me to see. So with this, okay, I try to fill up this part. Okay, so 0 to 1. Okay, 0 to 1. 0 to 1 is 1, don't care. Then next is 0 to 0 to 0 to 0. Okay, so all the 0 don't care. 0 don't care. 0 don't care. Okay, this is 1 to 1. So I got a don't care 0. 1 to 0 to 0 to 0. So it's a don't care 1, don't care 1, don't care 1. Okay, this one, 1 to 1, don't care 0. 1 to 0 to 0 to 0. So it's a don't care 1, don't care 1, don't care 1. All right. Then next, okay, this part here, 0 to 1. Yeah, 0 to 1 only. 0 to 1 is a 1, don't care. The rest are all 0 to 0. So you 0, don't care, 0, don't care, 0, don't care. Okay, so this is my this table here, and I arrange, okay, my this present state as in this form, similar to my Kano map. And based on this, okay, I'm going to fill in this Kano maps here. And in my list Kano map here, I try to arrange it, okay, similar to the order of my state table here. You see, I put Y1, Y2 here, vertical. Horizontal, the input, okay, X1, X2. Don't go and, okay, interchange these two in this case here. You are going to kill yourself only. Okay, so follow that state. Okay, vertical. All right, so I put here vertical. Horizontal for this one. All right, and for this case, this is a JY1, KY1, JY2, KY2. And remember, 1, 1, only 1, 0. Follow this so that easy for me to fill in. So you're going to find that, okay, I sort of basically like copy this one only because I arrange them properly. Okay, so first combination that I'm going to get here the state 1, right? State 1 labeled as 0, 0. Okay, this is my state 1, 2, 3, 4. Okay, double check. Okay. Okay, 1, 2, 3, 4. Exactly the same. All right, purposely arranged in this way to make it easier. And with this, okay, then now I'm going to fill in this one into here by just basically copy. So I put here 0, okay, for the J, X, okay, is for the K. All right, done. All right, then the second one, okay, 0, 1. So you find that I copy, okay, 0, 0, X, X. So do a little bit faster. So I finish this one first. Then 1, X, 0, X, 0, 0, X, X. And this is a X, 0. So I got 4X over here. Then this is 1, 0, 1. So if I make any mistake, please let me know. Okay, lastly, this one, 1, 2, 3, 4. Okay, this is 1, 1, 1, 1. Okay, continue with this. 1, 0, 0, 0, 1, 0, 0, 0. And this is all the X. Okay, this one here is X, all the 4X. 0, 1, 1, 1. 1, 2, 3, 4. 4X again. 0, 1, 1, 1. All right, this one here, 1. And here is 4X. Okay, so I hope I don't make mistake in filling up this Kanu map. So once I fill up this, okay, you'll find that next step definitely is looping. Okay, looping. So in this looping here, of course, okay, remember take the highest or biggest loop. Okay, JY1, same as your X1 bar, X2 bar, and this is the Y2. Okay, KY1, I have 1, 2, 3, 4 here. Okay, one loop. Then another loop. Okay, so KY1, you find that a little bit more complex. So this one here is going to give me Y2 bar. Okay, this one here give me the X1 bar, X2 plus one more is a X1, X2 bar. All right, this is a KY1. And for the case of JY2 here, yeah, this is a 1. Okay, both bar. This one, please, okay, when come to looping that time, be more alert a bit. Okay, so this is the one that I'm going to get. So it's a X1 for this one and X2 for this one. Okay, so students, okay, do all this already. Maybe they are going to forget about the Z. So you find that I never prepare any, okay, Kanu map for Z because, okay, only one. No matter how you look, it's still this one. So there's no need to prepare a Kanu map for this, okay. If you see this, straight away, okay, you can know that this one here is given by these combinations, X1, X2 bar, okay, Y1, Y2 bar. So Z is given by this expression. So don't waste time, okay, to go and prepare a Kanu map that eventually exactly the same as this one. All right, so you find that now the answer is here, and these are the equations. So with these equations here, of course, okay, my next step here is to build this circuit. Okay, so when building this circuit here, still remember how I cover? I will say that, okay, draw a few lines. So don't use red. Okay, draw a few lines. These few lines here, okay, is going to connect to my output of the flip-flops. So since I'm using 2 flip-flops, so I'm going to draw 4 lines. Okay, so you find that, okay, this is for my output of Y1, okay, output of Y2. So this one here forms your Y1. This is the Y1 bar. This is the Y2. This is the Y2 bar. Okay, So 4 lines for this output. On top of this 4 line, I got these 2 inputs. Okay, that is the X1 and X2. Now, don't forget that your X1, you got an X1 bar, isn't it? How to get my X1 bar? Actually, okay, I put an inverter to it. Okay, inverter to it. But for the case of Y, I never put inverter. This is because, okay, output of Y here actually come from flip-flops. Okay. So draw slightly bigger. Okay. I'm designing a synchronous counter. So students, okay, always forgot about this. Okay, so we better do it first. Then I'm using JK. Okay, and this is the Q bar. Q bar. And now, okay, you are going to decide, okay, which one you want to label it as your Y1, this one as Y2. Okay, let's say I go in sequence. Suka hati, okay, you can put Y2 first, then Y1, no problems. So as long as the connection correct. So in this Y1 here, this output here actually is the Y1 already. Okay, so I am going to tie it to my Q. Okay, and the Y1 bar tie here. That's why my Y1 here, I don't put inverter because it's not necessary. You get the Y1 bar from the output of your Q bar here. Same thing for the Y2. You connect to here. Y2 bar. Connect to here. Okay. And now, based on the equations, my JY1 is actually 3 input AND gate, which is connected to X1 bar, X2 bar, and my Y2 third line. Yep. Okay. Now the K is more complex, so I need to have a 2 AND gate. I may not have enough space. Okay, and okay, and 1 OR gate. And OR gate is 3 input. Connect to the K. Okay, first part here, this line here, I'm going to connect to Y2. Okay, the Y2, the Y2. Yeah, Y2 bar, correct? Okay, then this one here, well, if you were to look at the circuit here, of course, if you know lah, you are going to find that, okay, these expressions are, okay, I can make it same as X1 XOR with X2. If you know it, then you no need to draw something like what I'm drawing. No? You can just replace this one here with the additional gates here, which is the XOR gate. So to make it easier, otherwise, okay. So you find that I use XOR gate. So make it connect to just then you connect to X2 and your X1. Okay, X2 and your X1. So done for this one. And this one here is the bar. Okay, This one here is the OR gate. 1 and 2. So this is the 2. This is the 1. Okay, so seems like this design is correct already. Now, do I miss out anything? Do I miss out anything? Students always miss out, okay? A very important thing, my door will never open, okay, if without this, okay? Without this one here, my door will never open, okay? Or forever, I'm not going to have any output. Therefore, remember, okay, to add in these are AND gates here. All right, so your AND gate here, you connect to, so follow sequence on top first, Y1. Okay, over here, I think I don't want to join them. Okay, so I just label accordingly. I join it to Y1. I join it to Y2 bar. I join it to X1. Okay, I join it to my X2 bar. Okay, you can join to them or you just label, and my output here is the Z. So I managed to design this circuit here that can detect, okay, the sequence of 0, 0, 0, 0, then 1, 1, then 1, 0. Okay, don't remember the circuit, okay, remember how to design, enough already. Okay, so this is using JK. Same design, okay, I can make use of SR to complete the design, and this is the expressions that I'm going to obtain. All right, and I can also use, okay, T flip-flop. You find that more complex, but because the T flip-flop got only 2 input lah. You see my output here never change because my output never depends on the flip-flops, and at the same time I also can use D flip-flops for this design here. All right, and then after this, after getting it, of course, okay, draw diagrams. Okay, so subsequently, we try to revise how to fill in the SR here. So same thing, okay, if you want to do for the SR, remember your application table for SR. For SR, so you find that, okay, we do the same thing, but because SR having, okay, these are invalid, okay, invalid setting, you cannot have both S and R equals to 1, 1. Therefore, you find that, okay, the application table not exactly the same as the JK. So we try to recall this. So for me, okay, to remain as 0, 0, my set, okay, must be a 0. R can be a 1 or 0. For me, okay, to go to 1 here, set must be a 1. But R definitely got to be 0 because S and R cannot be both 1, 1. Okay. This one, for my output here, reset, okay, from 1 reset to 0. Make sure that R is a 1. S is a 0. Because you cannot take the conditions of toggle. So therefore, it's a 0, 1. Next, this is a 1, 1. 1, 1 here, you'll find that, okay, my R got to be a 0. So 1, 1, toggle, right? S can be a 1. Okay, S can be a 1. If S is a 0, sorry, not toggle, okay, remain. If S is a 0, they remain. S is a 1, they set. So this one here can be, S can be a 0 or 1. So you don't care. So this is the application table that I'm going to have for my SR design. So basically, okay, I'm going to do something like this. But of course, okay, this table here, we change a little bit. Change it to input to now it's SY1, RY1. All right, then we are going to fill in this table, or we can directly fill in over here. Okay, so let's try directly fill in over here based on the yellow and the green. Okay, with this application table. Okay, let me shift this one a bit. Okay, the condition we already know already. Okay, so what we want to see is these parts. Okay, this part. So for the case of SR, 0 to 0 to 0 to 0. For the case of first SY1 and RY1, 0, 0. So you find that it's a 0 don't care for all these four. 0 don't care for all these four. Don't care for all the four. Same. This is 1. Okay, first one is 1, 0. 1, 0. So it's a 0, 1. Then next, all these are 0. All these also 0. So it's a 0, 0, 0. Don't care, don't care, don't care. So I'm doing here as a 0, 0, 0, Q, and my Q bar, Q plus also 0. So it's a 0, 0. So I put 0, don't care. 0, don't care. Okay, third one is a 1. First one is a 1, 0. So you get a 0, 1 here. Second, 0, 0. So it's a 0, don't care. Third is a 1, 0. So it's a don't care. 1. Fourth is a 0, 0. So it's a 0, don't care. Lastly, all these are 0. This is am I seeing the wrong thing? Well, I may be seeing the wrong thing. I'm sorry, okay? I blur already. Okay, so I better erase all these. Okay, I make a mistake, okay? So sorry. See the wrong thing already. So what I need to see is this one. Okay, first one is a 0 or 0. So do it faster. Okay, 0. Okay, so it's 0 don't care for all. Okay, next is a 0, 1. First one, so 1, 0. Then 0 for all. Okay, 0 for all is a 0 don't care. Okay, this one 1, 1. Okay, and third one also 1, 1. So it's a don't care 1. All right, that one. So this is 1, 0. Both are 1, 0. So 1, 0 is a don't care. 0, 1. 1, 1. Yeah, 1, 1 is a don't care 1. Correct. Okay, next here is a 1. All are 0. So it's a 1, 0. So I'm going to get here as a 0, 1 for all. Okay, 1, 0, 1, 0, 1, 0, 1, 0. Okay, 0, 1 for all. Okay, so this is my table for SY1 and RY1. Okay, proceed with this part, or I just show you all, try to fill in on your own based on this. My eye really blur already. So now over here, looping. So of course you find it here more complex, okay, expression you are going to obtain. Why? Because lesser don't care now. Okay, so for this first one here, you loop it with, okay, this is the expression that you obtain. For the case of RY1, so you find that I can loop this one. Oh, sorry, no need. Just wonder I filled it incorrectly or not because my answer is not the same. Okay, my answer is not the same. I may be filling wrongly, okay? So I double check. So this part here is I didn't prepare for this part. So anyway, okay, I will double check, okay, then later on, okay, I upload. So just I filled up accordingly. My eye is a bit blurred already. Okay, so fill in accordingly and I'll get this thing done. All right, so I will sort of, okay, repeat this,
Miss,
get the ready one. Yep.
the third row is 0101
0101.
for the KY1. No, for the RY1, sorry.
Third row. This one. This one is it? So what is it?
No, Miss, actually that's column. I mean,
column.
row. Yeah.
Okay. Yeah, right. Okay, so what should I put here?
0101.
So now this column.
Same.
What is that?
Don't care.
Don't care.
Don't care. And this not I haven't.
This one here is what is this?
000. Don't care.
Don't care. This one also don't care.
One.
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 Okay, thank you. Okay, thank you. Oh, blur already. So with this, okay, of course we do looping. So this is answer is correct one. So you loop accordingly to get this answer. Okay, try out for this one and also the T flip-flop. So Monday when I see you again, I will show you the correct one for all, and I will return the test script to you all. I actually finished marking already, but actually I very disappointed. Right, so don't want to talk about it for today. So next week, okay, I finish this one, then only we talk about the answer for the test. Okay, so sorry for the mistake that I make. For the case of report, right, you submit as a group. So it doesn't matter if let's say you partner with Song Jian partner with I can't remember who. So if you partner with, say for example, Xian, then both of you only Xian, then you submit one enough already. Either you submit or Xian submit. So any more question? Deadline for submission is this weekend, Saturday. So do me a good report. Okay, any questions? Any question before we end this? Okay, so we stop here. And we continue next Monday. Okay, bye-bye. And everybody take care.